At WKRG Plus, we make weather easy to understand. This is WeatherWise.
Hello everyone, I am Chief Meteorologist Ed Bloodsworth with WKRG News 5 and welcome to our latest edition of WeatherWise. Of course, we talk a lot about weather here on planet Earth, but now we're going to discuss something else. We're going to go pretty far up. Now we are talking space weather. So this is the study of heliophysics, of the sun's influence on our magnetic field, and those beautiful auroras that we tend to see when we get those significant solar events. So let's first get right to the aurora. It's something that we know of. The northern lights in the northern hemisphere, it's the aurora borealis. In the southern hemisphere, this phenomenon is called the aurora australis. And this is still the same thing, no matter what hemisphere you're in. And this is a brilliant display of Earth's protective shield, what keeps us alive here and what allows life to thrive on our planet. This is a video taken in 2025, earlier this year, out of Victor, Idaho, with some of those farther north latitudes, and you get some of those brilliant colors, the greens, the purples, the pinks. Additional video, this is a look of the aurora as viewed from our friends floating high above the Earth in low Earth orbit. This is, of course, from the International Space Station, taken also in June of 2025. And notice in the atmosphere those bands of green and pink, especially once you get higher up, you see those pink shades there. And this is a complex situation happening with molecules of nitrogen and oxygen interacting with photons and particles, light particles that are coming off the sun that just bombard our planet at all hours of the day. In fact, we had brilliant displays of this locally. Take a look at this video. This is from Dauphin Island. Back in 2024, two instances, first in May and then again in October, where we had a major solar flare event that triggered significant auroral activity that was visible all the way down to the Gulf Coast, even all the way down to central Florida and central Texas. A very rare sight indeed to see that kind of auroral activity all the way down to the Gulf Coast, into Alabama and the Sunshine State as well. Absolutely amazing to see, and the time lapses were absolutely stunning. So let's go ahead and begin. What is space weather? Well, it's defined as the variations in the space environment between the sun and the Earth. So space weather is certainly something we have to watch because this can interfere with satellite electronics, radio communications, our GPS signals in our cars, and also those electrical power grids. And there have been some historical instances where significant solar activity has led to significant disruptions in our power grid. So this is something that NOAA certainly watches very, very closely when we get extreme solar activity breaking out and all those charged particles head towards our planet. To understand space weather, you have to understand the solar cycle. So what you're looking at here is a graph from NOAA's Space Weather Prediction Center. Yes, there is such a branch of NOAA, and what you're seeing is the amount of sunspots observed on our sun. And this shows you the solar cycle. It usually goes for about 11-year cycles when you get very little solar activity. That's what we actually saw back in 2020. Very few sunspots and very few CMEs, coronal mass ejections or solar storms emanating from the sun. But as we started to move towards 2024 and 2025, the sunspot activity increased dramatically during that time frame. And the area of red, that's the projection. So we anticipate that by the time we start heading towards 2030, that we will likely see much lower solar activity emanating from our life-giving star. Now, let's take a look at the aurora. So for a lot of us learned this in elementary school, so here's another reminder. It all comes from the sun and something called the solar wind. This is something that emanates from the sun and bathes our planet at all hours of the day, every minute, every second of the day. The solar wind, it's heat, charged particles that come off of the sun and travel the entire distance across our solar system. And this, the sun, of course, drives weather here on planet Earth. Now, the aurora is formed when you have the Earth's shield, our magnetic field. This is our big protective barrier that keeps all of these charged particles, these dangerous microwaves, from killing off all life on the planet. So if we did not have a strong magnetic field, life would not be possible here on planet Earth. Now, here's something to note with this auroral storm. Occasionally, you can get significant blasts of charged particles, much more particles than normal, and this is a solar storm. And this is something that we observe regularly from the planet Earth thanks to satellites. This is an example of one such solar storm. This is back in September of 2023, and this is a satellite, of course, pointed towards the sun. I want you to know, just after the black frame there, if you notice right in the middle, that sort of little eruption that you saw, you'll see it again here. Once you get past that little black frame right there, that is the solar storm, also called a CME, a coronal mass ejection. You can almost think of it like a volcanic eruption of charged particles that race out and emanate away from the sun. And those particles, there's plenty of them, and they really have some significant impacts on our aurora, and it's something that we see. So all of those charged particles start to emanate and get towards our poles. They all get funneled to the north and the south pole. And when you take a closer look at this and do a little chemistry here, those charged particles collide with molecular oxygen and molecular nitrogen, the two most abundant gases in our atmosphere. And those interactions, those collisions, excite all of those particles, the oxygen and the nitrogen, and that allows them to emanate colors. You see them, and they start to brighten up the sky, tremendous glow of colors. And the colors that you see from the aurora, well, it all depends on what molecules you're talking about. So, with those charged particles, as they interact with oxygen, they tend to release the colors in the reds and the green families here. Then nitrogen in our atmosphere, when those get excited by those charged particles, you start to see these form these blue and purple shades. And if you're in a situation where you're in the right spot, you can see all of these colors emanate during the night sky. Quite a spectacular thing to see, especially, of course, in those far northern latitudes. Here's another good example from Sutherland, Scotland. This was taken, again, Scotland, much higher up in latitude, where the auroras are a little more common. Of course, they don't get all the way down to the Gulf Coast. That's usually once in a generation kind of event. But this is much more common, obviously. This is actually a camera, a security cam, capturing the auroras dancing across the sky. Again, you can see those shades of purple and blue, so that would be the molecular nitrogen there. And then off in the distance, you see the little flashes of green. That would be the molecular oxygen, just getting excited by all of those charged particles during a solar storm event. So it's quite amazing. The photographers love to see an aurora come through because it really gives you a spectacular opportunity to see Earth's defense system, our natural defense system, in spectacular motion and spectacular glory. Gorgeous colors that you see. So when we talk about these geomagnetic storms, these bursts of charged particles, well, we have a way to measure them and a scale. So this is the geomagnetic storm scale. It goes from a scale of G1 being minor events to G5, the most extreme of events. And the reason why we have to pay close attention to this, of course, it causes a significant display of the aurora. And when you get into the G4, G5 level, you can get those auroras to form and be visible much farther south in latitude. But there's a practical reason why we pay attention to these as well, because of the impact that they could have on our power grids, on GPS, things of that nature. So when you start to get into the special G4 and G5 levels, that's when you could have some significant disruption within the power grids and blackouts. You can also have disruption in GPS signals. So your GPS would become a bit more unreliable. And even our communication to our orbiting satellites can be impacted by these most significant events. So case in point, the Dauphin Island video that we just showed you earlier, that occurred during a G5 event, and that makes sense. During this time of our solar cycle, when we're at our maximum, that we get more of these G4, G5 level events. So these can be significantly disruptive if we don't take the right precautions. Now, there's a lot of research that's being done specifically with these events here, trying to determine exactly the kind of impacts they have, and that allows us to better design more capable, more sturdy satellite systems so that we can protect ourselves from those significant coronal mass ejections or geomagnetic storms. Now, when you're out, the shape of the aurora that you see, well, there are a lot of factors that go into it. It really just depends on your perspective. So when we get a full display of the aurora, they can appear as waves, they can appear as sort of just straight lines, and if you're farther south in latitude, you can see them to the north. Most of the time in those southern latitudes, you're really not going to see them through the naked eye. You need some kind of device, something like your smartphone, for example. A lot of the pictures that we receive of these aurora events, especially farther south in latitude, are visible by just holding up your phone and looking off towards the northern horizon to see the brilliant colors of the aurora. So now you know all about the aurora and why we pay very close attention to these coronal mass ejections and solar storms. So we're still in the peak of our solar cycle here, so not out of the question that you can get some more significant solar activity that could trigger brilliant displays of the aurora. And boy, if you ever get a chance to see it, they are quite a sight to see, especially for areas that are not typically used to seeing the brilliant aurora borealis or aurora australis. And now you are Weather Wise. We thank you so much for joining us for the latest edition of Weather Wise. You can continue to watch previous episodes of Weather Wise on the WKRG Plus app. We have had episodes regarding flooding. We've had episodes regarding rip currents as well. And make sure you are on the lookout for future episodes of Weather Wise. We're going to be covering a lot of topics that may just pique your interest. I'm Chief Meteorologist Ed Bloodsworth with WKRG News 5, and on behalf of the entire News 5 First Alert Storm team, thank you for watching this edition of Weather Wise.